So we have made the cool observation that we can represent functions, some functions, with power series. So for example, we took note that 1 over 1 minus x could be represented by this power series, just, x to the n, provided that the absolute value of x is less than 1. Okay, so there we have a power series. Now, this particular power series that we're looking at here, this one, we say that this is a power series expanded about 0. So we've got this series, and it's a 1 plus x plus, if we expand it out a little bit, on and on. But that's a power series expanded about 0. Now, we can expand power series around other numbers besides 0. For example, think about this function I have here. I have 1 over, uh, let's just call it something. Let's call it f of x. We have 1 over 1 minus x. So here we have a function, and we think of it as the power function is expanded about 0. Well, think about what would happen if we did this. If we said, I want to shift this function over c units. Okay, so I'm going to do a shift to the right. This is just a horizontal shift. Well, that would look like this: 1 minus x minus c. Well, what would that do to this power series that we had? So we had this power series, which is 1 plus x squared. How would that change that power series? Well, all we do is we replace the x with x minus c. So this would be the power series or the summation from n equals 0 to infinity of x minus c to the n, or 1 plus x minus c plus x minus c squared plus. And now what we want to do is say, well, that provided that x minus c is less than 1. So that would be, instead of just saying the absolute value of x is less than 1, the absolute value of x minus c is less than 1. So let's look at an example. Let's suppose we have this function, 10 over 5 minus x, and we want to find a power series for that function, not centered at 0, but centered at 1. In other words, I'm going to convert this to a function where I have not x, but x minus 1 in there. So normally with a power series on the bottom, you have 1 minus x. Now I'm going to have 1 minus parentheses x minus 1. So let's see how we would go about that. Now, first of all, I need, for this bottom, this 5 minus x, I need it to equal this. I'm gonna use k minus x minus 1. Replacing that x with x minus 1, I'm going to need to do that. But I don't want the bottom to change its value. In other words, I want what's there now, the 5 minus x, to equal what's going to be there when I replace x with x minus 1. Now, what's going to change is this k right here, this 5. See, I had a 5 there. Well, what's going to happen when I put an x minus 1 in there? It's not going to stay a 5. It's going to change to some k. So let's see what it's going to change to. Let me just do some algebra here. I've got k minus x plus 1. These x's go away, and it looks like k is equal to 4. Just solving that equation, 5 equals k plus 1. So k equals 4. So here's what we have now. We have 10 over 4 minus x minus 1. There's what we have. Now you can see it's the 4 minus x minus 1. That's the same as 5 minus x. I mean, if you look at it, you got 4 minus x minus, put these two minuses together, makes a plus, and that would make a 5. So really, this thing, These two are equal. But now we have a situation where we're getting set up where we can find a power series expansion around x equals 1 or around 1. So here I'm going to divide by 4 because I still need a 1 here. So I get 10 over 4, and this is 1 minus x minus 1 over 4. Now I can just put that into my power series expansion. So look, I've got 10 4, which is 5 halves. N equals 0 to infinity. But instead of x to the n, I'm going to put x minus 1 over 4 to the n. And that will converge provided that x minus 1 over 4 is less than 1. So there's how we can make a power series expansion not about 0, but about some other number. So let's look at another example. Let's suppose we have 2 over 3 minus, let's say 4x. And we want to expand this about, let's say, -2, about -2. So here we go. I've got 3 minus 4x equals k minus 4x plus 2. Notice it's plus 2 because it was minus. It's x minus whatever you're expanding about. So let's see here. If I solve this, I get 3 minus 4x equals k minus 4x minus 8. Okay. And once again, these go out, and I'm left with k is equal to 11. Ah, now, so here's what we have. We have 2 over 11 minus 4x minus 2, or x plus 2. There it is. Now we're not ready to do our power series expansion. All we've done so far is we found out what this needs to be. In other words, we compensate for the fact that we no longer have x, we have x plus 2. So I replace the x with x plus 2. What does that do to this number here? Well, it was a 3 and now it's an 11. See, I just equate those denominators. Take this, replace the x with x plus 2, and then find out what this new number is going to be. Now I need a 1 where that 11 is, so I just divide. So it's 2 over 11 over 1 minus 4 elevenths x plus 2. Yeah, now we can write our power series. It's 2 over 11, and then in here we have 4 over 11 x plus 2 to the n, and that is true provided 4 over 11 x plus 2 is less than 1. So there we have it. Now, let's suppose that instead of let's look at the other way. Recall that we had made the observation that this is equal to the alternating series. In other words, when I put a plus in there, I've got -1 to the n, x to the n. Okay. Let's suppose that this is an alternating series. So if we end up with a plus in here, this is the series we're dealing with. So let's think about one that might suit us here. Let's suppose I've got 2 over, let's say 2 minus x, and we want to expand this about negative, or let's say 3. Let's just say 3. Well, I need to take this 2 minus x, set it equal to k minus x minus 3. See, I just have exactly what's in the denominator, and then over here I replace the 2 with a k and replace the x with a x minus 3. So we solve this, and dig what we get. We get 2 minus x equals k minus x plus 3, and that gives us k equals negative 1. So let's see what we've got now. We've got 2 over negative 1 minus x minus 3. Now I need to get a 1 in place of that negative 1, so I divide. So I get negative 2. Down here I get a 1. Now look at this, plus x minus 3. See, because I divide it by negative 1. Okay, now I'm ready for my power series. I've got negative 2. Because it's plus, I'm going to use the alternating. There, and we found a power series. Now this is provided, of course, that x minus 3 less than 1. So there's how we can find a power series representation for a function centered by something other than 0.